Hey everyone, thank you so much for watching Weaviate on YouTube. I think we have one of the most exciting recent breakthroughs in large language models, AI, and deep learning technology. MosaicML is open sourcing with a commercial license the MPT-30 billion parameter large language model. So we have three models that have been published. The MPT-30 billion, that's the pre-trained model. It's been trained by language modeling. It's just absolutely gigantic scale of text data. And then we have two tuned models from that checkpoint, MPT-30 billion instruct and MPT-30 billion chat. So two different ways of continuing the training with labeled data and that kind of thing for training from the checkpoint. So right off the bat about the checkpoint, obviously the open sourcing of that with a commercial license, that's probably the thing that jumps out the most when you read a headline like this. But there are all sorts of interesting details behind this, whether you want to take that checkpoint and start sampling from it to label your own your own feedback preferences, to then continue the training on MosaicML's training cloud, all sorts of interesting details of what you can do with the open sourcing of the pre-trained base model. And then of course what you could do by plugging in the 30 billion instruct model into your application. So the 30 billion chat model has been published with the demo, so we can get a quick sense of the intelligence of this thing by querying it on Hugging Face basis. So let's ask it, please write a short description of how approximate nearest neighbor search works. So we can test its intelligence on Hugging Face faces and get a sense of how this works. So it's hosted with the MosaicML Inference API. So quickly, the MosaicML Inference API is super interesting development with Mosaic and makes it super easy for us integrating it with Weaviate. Is they also have this kind of like inference as a service API where if you're used to Weaviate, we have like a generative OpenAI, generative Cohere, generative Palm, and so pretty soon we'll have generative MosaicML that lets you do this kind of connect to the inference service using your API key and running that on all the search results in parallel, and so on. So here's his answer. Please write a short description of how approximate nearest neighbor search works. Approximate nearest neighbor search is a technique used to find. So see, I think you get the idea. You can pause it and read it if you like. But so one more thing quickly before diving into the blog post where MosaicML has written all sorts of details about how this works. It's just such a detailed, comprehensive overview of what it takes to train language models like this, and as well as the evaluation of them. Let's take a look at retrieval augmented generation with this thing really quick. So our interest with vector databases, something that we're super excited about with large language models, is when you take a query like, let's say the query is, what is llama index? We take that query and we turn it into a vector, and then we use that to search our vector index of text passages that have also been vectorized by doing that, vector distance calculation to find the nearest neighbor. And then as you saw with the approximate nearest neighbor search, the meat of that is building up the data structures to let you scale that to an absolutely enormous scale and not have to do the distances between every single vectorized passage in your text collection. But so we might ask a question like, what is llama index? And then we would hit some data source like say the Weaviate blog post. And we recently have this new blog post from Jerry Liu, llama index in Weaviate, and say that vector hits the vectorized, the vector representation for this text chunk. We grab that, and then to the large language model, we would say something like, please summarize this text, and then we give it the text retrieved from the vector database. Or say, please answer this question based on the following text passage. All these kind of things that you can do with it. But we see the answer. Llama Index is a data framework for building LLM applications. It provides connectors for ingesting data from various sources. So, it provides a successful answer. So let's dive into the blog post, get into all the details behind how the MPT-30 billion model was trained and evaluated, and this just super exciting development as the open source large language models and just generally the capabilities of these models continues to evolve. All right, let's get into the details of it. MPT-30 billion, open source large language model, commercially licensed, more powerful. So one of the first things that jumps out when you read this is 8,000 context length on H100 GPUs. I believe H100s are the most powerful GPUs, so it's impressive to have set up that kind of cloud infrastructure for all this. So they begin the story with, well, firstly, you can check out the chat on the Hugging Face, which is what we just looked at. So beginning the story, so MPT-7 billion, this model, I think it came out 1 or 2 months ago, and they describe how in May alone, these models, the 7 billion parameter base, instruction tune, chat tune, and story writer, which I think is another specific data set that they fine-tuned the 7 billion base on, have been collectively downloaded over 3 million times. So clearly people are interested in these open source large language models. There's no dancing around that. So to tell a little more about the story of open sourcing the MPT 7 billion base, they describe how the community has, extended MPT with Lava MPT, which adds vision understanding to MPT, this new GGML inference library that optimizes MPT on Apple Silicon and CPUs, and then GPT for all, which lets you run a GPT-4-like chatbot interface on your laptop using MPT as the backend model. So this is like this private GPT that comes with the UI for your local setup, and you can use MPT as that model to run on your laptop. So today we're excited to expand the MosaicML Foundation series with MPT-30 billion, a new open source model licensed for commercial use. This is a huge detail that is significantly more powerful than MPT-7 billion and outperforms the original GPT-3. So pretty amazing. They later describe 17% of the parameter count of GPT-3, and they use about 60% of the compute budget to achieve this. So they're also releasing two fine-tuned variants, MPT-30B Instruct and MPT-30B Chat. We'll get into that and what that entails, that are built on top of MPT-30 billion. They describe, I think it's so interesting how they're describing, they publish the base model as well, which has been pre-trained with the language modeling, as well as these models that have been fine-tuned with that instruction tuning, the whole reinforcement learning from human feedback, where you have some kind of instruction and then a long answer and then the human preference, do you like this? Or the chat conversation. Interestingly, the chat conversation model actually isn't commercially licensed, but and I don't think there's detail about exactly what data set that is trained with, but that's where you have multi-turn conversations to fine-tune with. So, but they also released the base model. So if you want to take that 30 billion parameter base model and then, you have some kind of instruction tuned data set for your particular thing, you could continue training with that base model. And it's one of the most interesting trends that I expect to develop further with this whole continued evolution of large language models. So they're all MPT-30 billion models come with special features that differentiate them from other large language models. So the 8,000 token context window, that's pretty long. I think 4,096 is what I think is currently on the OpenAI APIs, and obviously that's like 8,192. But anyway, so longer context via alibi attention. So alibi attention seems to be a big deal, so I wanted to just quickly highlight this paper. The title of it, Train Short, Test Long. So it's an interesting way that they can extend the context length at inference time if you're not interested in the full details of like how exactly they modify attention. But that's something they say, like if you look at when you're configuring MPT-30 billion, you can turn it up to 16,000 context window, and that's a property of how this alibi attention works. I'm personally not an expert on that, but just taking out that nugget of it quickly. So also you have the pre-training data mixture. So they're going to show a table that has the composition of data sources, another quite interesting detail. And then again, the H100s are, I think, the most powerful GPUs. So this kind of cloud infrastructure stuff has been set up. So another really interesting thing is that you can deploy it on a single GPU. So either you would need one A100 with 80 gigabytes in 16-bit precision, or one A100 40 gigabytes in 8-bit precision. So the ability to deploy this on a single GPU, that's also quite interesting because it makes it easier to deal with the computing cluster if you only have to have one GPU to deploy the model onto. So comparable models such as Falcon 40 billion, they have larger parameter counts and they can't be served on a single GPU today. So that necessitates 2+ GPUs, which increases increases the system cost as well as kind of the overhead of how you're going to think about doing this. So some additional interesting things, MosaicML training, if you're going to keep training with the 30 billion with your private data via fine-tuning, domain-specific pre-training, or training from scratch. I think that is such an interesting detail, and it'll be so interesting to see how that plays out. They also have MosaicML Inference, and we're going to dive into that later as well. So continuing further into the MPT-30 billion family. So they start off by saying customers can train MPT models efficiently with 40 to 60% MFU. So I wasn't exactly sure what this was, so I checked this out. Super cool repository, LLM Foundry. I've been familiar with MosaicML's Composer library. Composer is an open sourcing of all sorts of efficient training techniques for deep learning models. So like different kinds of regularization strategies, like particular kinds of dropout, or say particular kinds of like normalization layers, like ghost batch normalization, these kind of innovations like the alibi attention. All this stuff has been packaged in the Composer library, and now LLM Foundry looks like another library of open sourcing all these details. It's like huge detail to love about MosaicML. So this MFU metric, model flops utilization. So like how much of the hardware is the model utilizing when it's training. And I think, again, I'm not an expert on this myself, but there's all sorts of stuff behind, like how they try to reduce idle GPU time with how they batch the data. And they describe like this fully sharded data parallel thing and all sorts of interesting details of trying to, make the most of all the resources for training these models. So all sorts of things without diverging from loss spikes. Loss spikes, another thing, as you're doing the gradient descent and these kind of things. This is the kind of training techniques that come into that composer library, I think, to try to, control the training of gradient descent, language models, massive scale, that kind of stuff. So cool. So MPT 30 billion base, the commercial Apache 2.0 license, that's a really interesting details. Competitive with other open source models such as Llama 30 billion or Falcon 40 billion. They have this interesting chart we'll get into in a second. So I don't think any of these details quickly. So train with a long context window of 8K tokens versus 2,000 for Llama and Falcon. Can handle arbitrarily long context windows via alibi or with fine tuning. So again, this alibi train short, test long, so they can extend the context window after training the model. They don't need to train it with the 16,000, 32,000 to then extend it. So I think that's a pretty interesting detail. So to build 8,000 support into MPT 30 billion, we first pre-trained on 1 trillion tokens using sequences that were 2,000 tokens long and continued training for an additional 50 billion tokens using sequences that were 8,000 tokens long. So interesting detail. First, I think, heating up the pot with 1 trillion tokens on 2,000 token sequence lengths, and then continuing the pre-training, still like language modeling, predicting the next token, but 50 billion tokens on the 8,000 token length. So just details about how this kind of thing is, happening with the longer context windows. Okay, so here's a super interesting table, MosaicML MPT 30 billion training data. So you have the C4 corpus. I think this is like the, the colossal common crawl corpus where you hit the internet and get all sorts of data out of it. Red pajama, I've heard that phrase, but I'm not an expert on these kind of things. But, Wikipedia, I have to imagine the stack maybe is Stack Overflow, Semantic Scholar. So I'm not exactly sure. Oh, Stack Exchange, that's probably Stack Overflow like thing. So books, archives. So you can see basically the number of tokens that these data sources make up. So Wikipedia, it looks like, is only 5 billion tokens relative to this, C4, which is 2.4 trillion. These kind of details are so interesting. I think there's a paper called Doromai, something like that, where it's about optimizing the composition of data sources in pre-training. So as a reminder, this is used to pre-train the language model. So this is where it's predicting the next masked out token, not where you're doing that instruction tuning where you have it write a big long thing and then you say, how was that? And then you fine tune it that way. This is just like building that base language understanding from pre-training on predicting the next token on internet text, basically. Cool. So you see this bar chart that shows the size. You see Wikipedia, not as much as the C4. And then you can see, this is a really interesting detail as well, the sequence length distribution. So, where it's greater than 4,096 tokens compared to the baseline, and the baseline is, I think, this 2,000 context window. So maybe interesting, how the context is isolated. I'm not an expert on this detail as well, but say the Wikipedia passage, I imagine, is only 3,000 tokens long, somewhat, I don't know, just like randomly like some small city or something that made its Wikipedia but isn't like an 8,000 token sequence. So maybe that's what they're showing with this plot. I'm not exactly sure. Okay, so continuing on, here is my favorite part of the blog post. They show the evaluation of their model with this kind of diagram, and so funny enough, I remember this from playing Pokemon, where your Pokemons would have different dimensions in this one kind of game. But anyway, so this kind of chart, I don't remember exactly what this kind of chart is called. That's why I referenced the Pokemon thing. But you have the how well it performs in symbolic problem solving, programming, world knowledge, language understanding, reading comprehension, and common sense reasoning. So 0.4, 0.6. This is all the single metric for this particular aspect of language understanding. So you see MPT 30 billion in red, MPT 7 billion in black border, purple shading. So you see reading comprehension, the new model is much better. Maybe say symbolic problem solving pretty similarly. And so it's such an interesting chart because there are so many different dimensions to evaluating these language models. It's probably one of the most interesting topics, because you're trying to like boil the ocean, is something Zane said one time that really stuck with me. But you're trying to boil the ocean, where you're trying to language model, all of these data sources. So in the end, it's quite interesting to see like which particular types of thing, like how well can it write code, or how well can it write an essay on the Great Gatsby. So this kind of evaluation I think is really cool. So in addition to, let me zoom in on this a bit. So in addition to the comparison of 7 billion versus 30 billion, they also have MPT versus Falcon 40 billion, as well as Llama 30 billion. So probably I'm not an expert on Falcon or Llama, or expert, like knowledgeable of it that much, honestly. So like of what kind of licenses they have is another detail people probably care a lot about, like whether it's commercially licensed or not, or like MPT-30 billion, they've open sourced the weights, and they also have all this infrastructure behind fine tuning it. So I think that it performs similarly is interesting. Maybe it's another bit or less in scale is all you need kind of thing, but so performing about the same as Falcon and Llama is what I'm trying to get at. And then similarly with the 7 billion. Okay, so the next super interesting detail is the MosaicML inference and training cloud. So starting off with the MosaicML inference cloud. So I think it's so interesting that MosaicML is, getting into an inference cloud. This makes it a lot easier for us to integrate it with Weaviate and all sorts of cool things. So firstly, right off the bat, 4 times cost savings for the 30 billion instruct versus the OpenAI DaVinci checkpoint. Also 4 times cost savings for the 7 billion instruct versus the OpenAI Curie model. So I don't want to get into MosaicML and OpenAI. We're friends with both of them at Weaviate, but this is what they're showing you on the cost of these 2 different models with the inference APIs. So they describe the commitment to privacy, and then here's a super interesting thing is customizability. So MosaicML's training cloud, they've always been focused on training and how you would have a custom large language model for your data. And I think it's going to be super interesting to see how this plays out and how much people want this. It's very interesting from the perspective of like retrieval augmented generation, where you just retrieve with the search models vector database to have to GPT-4 that has knowledge, that has just this general reasoning ability that just reasons over the retrieved context, or whether it makes sense to keep this is the reasoning model, to keep fine-tuning the reader model, large language model, so then it retrieves some information about, say, Weaviate, and then this model has been RLHF'd with responses about Weaviate, and then does that lead to better answers? Is it worth the trouble? Super interesting questions, and I'm really interested to see how this shakes out. But with MosaicML's cloud, and also just the the publishing of the model, so this headline: customize MPT 30 billion with MosaicML training. So let's conclude with the training cost behind training these new models. So they describe with 512 A100 40 gigabytes, this takes 28 days and costs $871,000. So then with 512 H100s with 80 gigabytes, this takes 11.6 days and $714,000. So I think this is still, quite a breakthrough from how much the original GPT-3 cost to train. I mean, 512 H100s, the reason it makes me laugh is because, it is just an absolutely enormous computer if you think about it. And then, running it for 12 days, doing all this, and it's just remarkable what it's able to do. Just this whole state of this technology is really remarkable. But MosaicML, they've been really good at getting these costs down, so it'll be really interesting to see how this further plays out. So they also describe the cost of fine-tuning on 1 billion tokens with MosaicML. So I think this is really interesting. So if you want to have a 16 H100 80 gigabyte cluster, to fine-tune on 1 billion tokens, it'll take 9 hours and only cost $714. So that's pretty reasonable to pay for something like that, and all of it is managed on the MosaicML cloud. So and they're being super open about giving you all these details behind how it all works, open sourcing the LLM Foundry library, Composer, writing blog posts like this that explain everything. So the whole thing is just extremely interesting. If you wanted to, 1 billion tokens, I think, is quite a lot. So if you were to start annotating a data set of instruction tuning responses, you have this MPT 30 billion model. It's been open source, so you can start generating some responses from that, labeling which ones you like, which ones you don't, and then only $714 to see how well that improves the model or not. So super interesting detail. They describe signing up for the demo with the Inference API, and again, it's on Hugging Face Spaces. So Thank you so much for watching this video on MosaicML's MPT 30 billion models. Super exciting development for large language models and open sourcing them with commercially licenses, all the details behind all these things. If you want to learn more about Weaviate, please check it out on weaviate.io. You can also check out the open source GitHub repository of the Weaviate vector database on github.com/weaviate/weaviate. And also please follow us on Twitter at weaviate_io. Thank you so much for watching this video. Please subscribe to this YouTube channel if you want to see more videos about deep learning technology, vector search, vector databases, and all these exciting things. Thanks again.